We have found more than 6,000 planets. The number goes up most weeks. And in all of them, plus the 8 at home, there is exactly one place where you could open a door, step outside, and not immediately need a pressure suit. One. It is not Mars. Mars will kill you in about 90 seconds. Kevin's going to find the one. He's going to find it by dying everywhere else first. And then we're going to leave the solar system. Because finding it doesn't help. The moon. Everyone knows this one's bad. Let's get it on the board. No spacesuit, by the way. Kevin gets a t-shirt. Because a spacesuit is just a tiny Earth you're wearing, and how long do you survive inside a tiny Earth? Is a boring video. He gets dropped from orbit. The clock starts when he lands. It stops when he does. He steps out. He does not explode. He does not freeze solid. Both of those are films lying to you. What happens is quieter. The air in his lungs leaves fast, whether he wants it to or not. 15 seconds later, the oxygen already in his blood finishes its last lap to his brain, and Kevin goes to sleep. 75 seconds after that, the sleep becomes permanent. 90 seconds. Door to door. 120 degrees in the day. Minus 170 at night. Neither killed him. In a vacuum, there's nothing to carry the heat into you. One number before we go on. 90 seconds. Roughly. How long an unprotected human lasts in a hard vacuum? 3 of the next 4 worlds give Kevin exactly that. One of them gives him 1 second. I'm not telling you which. Pluto's going on this board. I'm not taking questions. Mercury. Closest planet to the Sun. 430 degrees. Hot enough to melt lead. This one should be spectacular. He steps out. 90 seconds. That's the same number. It is. Moving on. Right. Mars. Mars is different. Mars has an atmosphere, weather, seasons, ice, a sky that goes a color. We're planning to move there. There are people alive today who intend to die there. Mars is going to be different. Mars's atmosphere is about 6 millibars. Earth's is 1,000, 0.6% of our air. It is, functionally, a rumor of an atmosphere. Enough to blow dust around and make the sky look nice and do nothing whatsoever for the inside of a human being. He steps out. 90 seconds. Mars is the moon with weather. A beautiful, fascinating, scientifically extraordinary place. And to your body, it is indistinguishable from standing on the moon. Your lungs cannot tell them apart. Okay, you've noticed. Because space isn't killing Kevin. Space isn't doing anything. Space is empty. That's the entire point of it. The thing killing Kevin is Kevin. Which is exactly why there's one place where it never starts. Here's what nobody tells you about vacuum. You are full of water, blood, saliva, the wet lining of your eyes, the film of moisture inside your lungs. About 60% of you is water, and water has an opinion about pressure. Water boils at 100 degrees, but only at the pressure you happen to be standing in. Drop the pressure, and the boiling point drops with it. On top of Everest, water boils at 70, and you cannot make a decent cup of tea. Keep dropping it. Keep going. At about 6% of Earth's atmosphere, water boils at 37 degrees. Which is the temperature of a person? That line has a name. It's the Armstrong limit, the altitude above which you begin to boil at your own body temperature. Not burn, not freeze, boil. At room temperature. Because you brought the water with you. Now the myth, because everyone gets this wrong. Your blood does not boil. Your arteries are a sealed, pressurized system. Your heart is, among other things, a very good lid. But the lid only holds while it's beating. On the low pressure side, in your veins, vapor forms anyway. That's what stops the heart, about 15 seconds in. What boils is everything not sealed in. The water on your tongue, the film on your eyes, the lining of your lungs. You swell, roughly double. And your skin, far tougher than films give it credit for, holds you together. You don't pop. You inflate. We know all this precisely because it happened to a man. 1966. NASA. Jim LeBlanc is testing a prototype spacesuit in a vacuum chamber, and the hose that pressurizes it comes loose. His suit goes from normal to almost nothing in about 10 seconds. He stayed conscious for 14. The last thing he remembers before he passed out is the feeling of the saliva on his tongue starting to boil. They blasted that chamber back to breathable in 87 seconds. A chamber that normally takes half an hour. He woke up on the way. He had an earache. That was it. He went back to work, became a division chief at NASA, and spent a career building the suits that stopped it happening to anybody else. Which tells you the other half of this. 90 seconds isn't a wall. It's a deadline. It's the last moment somebody could still pull you back. And nobody is coming for Kevin. Venus. Earth's twin. Same size, near enough. Same rock. Next door. 4 billion years ago you would not have confidently picked the winner. Kevin's here because you clicked something. Do it again, and he gets Jupiter. He steps out. 1 second. What got him is a cue. The pressure is 92 times Earth's, 900 meters under the ocean. That doesn't crush him, he's mostly water, and water doesn't squash. It just collapses every airspace he's got. So he's flattened from the inside. The surface is 465 degrees. Hot enough to glow. So he's cooked. And, on the way down, he fell through 50 kilometers of sulfuric acid cloud. So he's dissolved. Flattened, cooked, and dissolved. And the dissolving happened first, on the way to the other two. Here's the part that'll bother you. 50 kilometers up, Venus is 1 bar. Sea level pressure. And 75 degrees. 5 kilometers higher. It's 27 degrees, and half a bar. Somewhere in that band is a layer of Venus that's near enough. A hot afternoon in Athens, floating above the worst place in the solar system. You'd need a mask and something acid-proof, and you would be fine. But I said you could stand somewhere. There's no floor. Doesn't count. So let's talk about you. You've watched Kevin die on other people's planets for 10 minutes, and I think you feel fairly safe. The Armstrong limit, the pressure where you start to boil, isn't a fact about space. It's an altitude. And altitudes are here, 19 kilometers up. Not in space. Space is 100. This is 19. A fifth of the way. There is a line in the sky above your head, right now, and if you crossed it without a suit, the water on your tongue would boil. It's the same line that got Kevin on Mars. It just happens to be above you instead of under your feet. Everest is 9. People stand on top of Everest. You do not live on a safe planet. You live in a thin, habitable film on a rock, about as deep as the clouds. And the only reason your 90 seconds hasn't started is that there's a specific weight of air sitting on you at this exact moment. It is the only thing between you and every number on this board. Earth isn't safe. Earth's just got a lid. Jupiter, Saturn, Uranus, Neptune. None of them have the one thing this video is built on. There's no surface. Nowhere to stand. The clock can't start, because Kevin never lands. So he falls. There's no oxygen. It's hydrogen and helium. And here's the strange part. The pressure is fine. At the top of Jupiter's clouds, it's about the same as it is where you're sitting. Nothing boils. Nothing swells. He gets 5 minutes. Longer than anywhere else we've been. Because the pressure was never the problem. It was only ever the oxygen. But that isn't the interesting part. He keeps falling. The atmosphere gets thicker and hotter. And he never stops. Because, to float in Jupiter, you'd have to be as dense as Jupiter's air. And it doesn't get that dense until you're halfway to the center, where it's 2 million times Earth's pressure and hotter than the surface of the Sun. There's no floor. There's no bottom. There's no wreck to find. There's just down. Until there's no Kevin. He didn't land on Jupiter. Jupiter dissolved him. Saturn's the same, but colder. Uranus is the same, but colder and tipped on its side. Neptune's the same, but with the fastest wind in the solar system. Which made no difference at all, because Kevin was asleep before he noticed the weather. Io. Jupiter's moon. This one has a genuinely exotic way to die. Jupiter's magnetic field is 20 times stronger than Earth's, and Jupiter's enormous. So that adds up to a magnetic structure 20,000 times bigger, which has trapped a belt of radiation so violent that standing on Io would give you a lethal dose in about 4 hours. Kevin gets 90 seconds. The radiation doesn't get a turn. Space has 1,000 ways to kill you, and never gets to use any of them, because the boring one always wins first. Vacuum doesn't have to be creative. It just has to be everywhere. Which brings us to the one. Titan. Saturn's biggest moon. Titan has an atmosphere, not a rumor of one, a real one. Thick, nitrogen mostly. The same as the air you're breathing right now. And here's the number that makes Titan the answer to the question I asked you 14 minutes ago. The pressure on the surface of Titan is 1.45 bar. That is not close to Earth's. That is more than Earth's. Stand on Titan, and the atmosphere presses on you slightly harder than it's pressing on you now. Nothing boils. Nothing swells. The 90 seconds never starts. You'd need a mask because there's no oxygen. And you'd need a serious coat because standing there in ordinary clothes would pull the heat out of you about as fast as being dropped into ice water. But a mask and a coat is not a spacesuit. A mask and a coat is camping. And then there's this. Titan's gravity is about 1/7 of Earth's. Its air is 4 times thicker than ours, which means if you strapped a pair of wings to your arms, you could fly by flapping like a bird. A human being on Titan in a parka could take off by flapping their arms. 7 years to get there, by the way. 7 years in a metal tube, drinking your own recycled everything, and at the end, you step onto a beach of water ice so cold it behaves like granite, next to a lake of methane, under an orange sky you can barely find the sun in. And it rains. Slow, fat drops, falling in that low gravity like they've got all day. It rains natural gas. That's the winner. The best address in the solar system that isn't this one. A cold beach where it drizzles camping. Stove fuel. And that's everything. Every world we can reach. We checked them all. So, we looked further. Since 1992, we've found more than 6,000 planets around other stars. Every few months, one of them is in the news as the next Earth. Earth's twin. Earth's cousin. Potentially habitable. Here's what potentially habitable means. It means the planet is the right distance from its star for liquid water. If it has a surface, and if it has an atmosphere, and if that atmosphere is the right thickness, and if it isn't being sterilized, and if. It's called the habitable zone. And it is a distance. It is not a promise. Because here's what nobody puts in the headline. Mars is in the habitable zone. Start with the nearest. Proxima b. 4 light-years away, which is next door, which means it is 4 impossible years away. At least Earth's mass, in the conservative habitable zone. The best placed planet we know of. It orbits its star in 11 days. That's how close it has to sit to be warm. Because its star is a red dwarf. Small, dim, and mean. At that distance, Proxima b is very likely tidally locked. One face to the star, forever. One face in the dark, and if it has an atmosphere at all, the models say the water is on the day side. An ocean eye, staring at its star for eternity, ringed by ice. Which is the most beautiful sentence in this video. And I need to ruin it. In 2016, we watched Proxima put out a flare several times more powerful than anything our sun has ever managed. For a few minutes, it was bright enough to see with the naked eye. It does that 5 times a year. Smaller ones, every day. We don't know if Proxima b has an atmosphere. We know it's the right distance. We know something keeps trying to take its air away. Kevin gets 90 seconds. Probably. We genuinely can't tell you. Then there's the famous one, Kepler 452b, Earth's cousin, front page, 2015, 1800 light-years away. Here's everything we know about it. Roughly how big it is. How long it takes to go round. That's the list. And in 2018, we stopped being sure it's there. A reanalysis last year says it probably is after all. The catalog still carries a warning label. Earth's cousin. We are arguing about whether it exists. Which brings us to my favorite object in the galaxy, and the strangest answer this video has. Not every planet has a star. Some got thrown out, slingshotted by a bigger planet, out of their orbit, out of their system, out into the space between the stars. They're called rogue planets. And there may be more of them out there than there are stars. The most common kind of planet in the galaxy might be the kind with no sun at all. Just worlds. Drifting. In the dark. Between everything. There is no day on a rogue planet. There is no night either, because night is a thing that ends. No sunrise, no sunset, no seasons, no shadows. Nothing has ever cast a shadow there. The surface is a few dozen degrees above absolute zero, so obviously it's the worst place we've looked at. Except, a planet doesn't only get heat from its star. It gets heat from itself, from radioactive elements decaying in its core. Earth does this. It's why there's lava. A star just throws that heat away, unless something's holding it in. In 1999, David Stevenson worked out that a rogue planet with a thick enough hydrogen atmosphere could trap its own internal heat well enough to hold liquid water on its surface. No star, no light, just a planet keeping itself warm for billions of years. An ocean in total darkness that has never once seen a sunrise. And it doesn't have a habitable zone problem, because it isn't in one. There's nothing to be the right distance from. So, could you stand on one? The pressure would be fine. The temperature at the surface of that ocean would be fine. You'd need air and a boat. And you would never see anything again. No horizon. No stars. The atmosphere's too thick. No sun, ever. Just a lid over an ocean, forever. In the middle of nowhere. Going nowhere. It's habitable. Nobody said it was nice. So, the final board. Almost everything gets 90 seconds. The gas giants give him 5 minutes, which is somehow worse, because he spends them falling. Venus gets 1. Titan gets a coat. The best candidate we have for a second. Earth might be a rock in total darkness that we haven't found yet. And then there's this. 80 years, give or take. Not because Earth is kind. Earth is a rock that boils you, 19 kilometers above where you're sitting. 80 years. because down here, there's a specific weight of air on your chest right now, and it's the only thing on this board that ever went right. I told you there was one place you could step outside without a pressure suit, and that it wasn't Mars. It was Titan. It was always Titan. But you weren't looking for a place you could stand outside. You were looking for a place you could stand outside and just breathe. And out of 6,000 planets, we have found exactly one of those. You're on it.